Here in this video, I'm going to give some sample solutions to very important sums based on inverse trigonometric functions. There are three kinds of sums. First one is where we need to prove an equation, that is we need to prove the left hand side is exactly equal to the right hand side. And the second type of questions are those where we need to simplify an expression. That is, we need to write a given expression in the simplest form. And the third kind of questions are those where we need to evaluate an expression given in the form of inverse trigonometric functions. So first, I have taken the first type of sum where we need to prove that 2 tan inverse half plus tan inverse 1 upon 7 is equal to tan inverse 31 upon 17. So let's take the left hand side, that is equal to 2 tan inverse 1 upon 2 plus tan inverse 1 upon 7. Always remember that if the coefficients of inverse trigonometric functions are not equal, that is unity, we must make them equal. So as you see there, the coefficient of tan inverse half is 2 and tan inverse, the coefficient of tan inverse 1 upon 7 is 1. So first we have to make the coefficient of this trigonometric functions as unity using any one of the formula. So as we know well, we have three formulae for 2 tan inverse x. One is 1 minus sine inverse 2x upon 1 plus x square. Other is 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square. And the third one is 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Now the question is, which of these three identities we have to use? So the trick is, where we have to use any one of these three identities, we have to see the other trigonometric expressions whose coefficient is already unity. If this inverse trigonometric function is given in sine inverse form, then we have to use this formula. If this is given as cos inverse, we have to use this one formula. And if this is given in terms of tan inverse, as it is given here in this sum, we need to use this formula. So tan inverse x is equal to tan inverse 2x upon 1 minus x square. So let's use this identity over here. Here x is half, so we get tan inverse 2 into half upon 1 minus 1 upon 2 square plus tan inverse 1 upon 7 as it is. Now this 2 will cancel this 2, and in the numerator we get 1 tan inverse 1 in the numerator, and in denominator we have 1 minus 1 upon 4 plus tan inverse 1 upon 7. So tan inverse 1 upon, here we simplify 1 minus 1 upon 4, we get 3 upon 4 plus tan inverse 1 upon 7. So as you know, 1 upon 3 upon 4 may be written as 4 upon 3. So we get tan inverse 4 upon 3 plus tan inverse 1 upon 7. Now both the tan inverse functions have the coefficient unity. So we have to use formula now for tan inverse x plus tan inverse y, which is equal to tan inverse x plus y upon 1 minus xy. So tan inverse, x is 4 upon 3 and y is 1 upon 7. So using this identity we get tan inverse 4 upon 3 plus 1 upon 7 upon 1 minus 4 upon 3 into 1 upon 7. So simplifying this, we get 10 inverse, and in numerator we get LCM, which is 21, 3 7s are 21, and now dividing 21 by 3 we get 7, 3 7s are 21, 7 will multiply 4, 7 4s are 28, plus 7 will divide 21 3 times, and 3 will multiply 1, 3 1s are 1. So in the numerator we get 28 plus 3 upon 21, and in denominator simply if we multiply 4 upon 3 and 1 upon 7 we get 4 upon 21. So here we take LCM 21, and 21 will multiply this one, get 21 minus 4. So LCM is cancelled by LCM, and finally we get 10 inverse 28 plus 3 31 upon 21 minus 4 17. So we get finally 10 inverse 31 upon 17, which is exactly equal to the right hand side given in the question. So we write this is equal to right hand side. Now we have taken the second type of sum where we need to write an expression in the simplest form. So this is 10 inverse under root 1 plus x square minus 1 upon x. One more important thing here is very essential to be explained, and that is that particular kind of sums where we need to write the expression in the simplest form. There are again two types of sums. In one type there is an algebraic expression with any inverse trigonometric function, and the other is where there is a trigonometric function or trigonometric expression with an inverse trigonometric function. So here we have taken the first kind, that is an algebraic expression with a trigonometric expression, inverse trigonometric function. So here we always use to substitute something for x. So here let x is equal to tan theta. So we see what happens. Tan inverse under root. First we write the original expression as it is, and then we start substitution. Is equal to tan inverse under root 1 plus x square, that is 1 plus tan square theta minus 1 upon tan theta. And as we know, tan inverse as it is, as we know 1 plus tan square theta is sec square theta, so we have under root sec square theta minus 1 upon tan theta. And since square eliminates the square root, so we get tan inverse sec theta minus 1 upon tan theta. Now tan inverse, now we have to write sec and tan both in terms of sine and cos to simplify further. So sec is 1 upon cos, so we write 1 upon cos theta in place of sec theta minus 1 as it is upon tan theta, and tan theta is equal to sine theta upon cos theta, as you know well. Now tan inverse, in the numerator we take LCM cos theta, so in the numerator of this fraction we get 1 minus cos theta. This expression is in the main numerator of this expression. In denominator we have sine theta upon cos theta. So the denominators of denominator and numerators are cancelled because these are identical, and we get tan inverse 1 minus cos theta upon sine theta. Now tan inverse, always remember when we come across an expression like 1 plus cos theta or 1 minus cos theta anywhere during our calculations, we always try to eliminate 1 using any formula of cos 2 theta. So here we have to write for cos theta 1 minus 2 sine square theta upon 2, because by the formula of cos 2 theta we have 1 minus 2 sine square theta. So always remember, in this identity there is the angle which is double of this angle, or in other way we may say that here is always an half angle of this one angle. So if we use this identity for theta, as here we have cos theta not cos 2 theta, so we have to make this angle half of this angle, so we get 1 minus 2 sine square theta upon 2. So in denominator we have sine theta. With the same logic, using the formula of sine 2 theta, we may write it as 2 sine theta upon 2, that is the half of this angle, into cos theta upon 2. So tan inverse, now open the bracket, 1 minus, this minus will change both the signs, so 1 minus 1 plus 2 sine square theta upon 2 divided by 2 sine theta upon 2 cos theta upon 2 as it is. Here in numerator, plus 1 minus 1 are cancelled with each other, and we get tan inverse 2 sine square theta upon 2 upon 2 sine theta upon 2 cos theta upon 2. Here 2 is cancelled by 2 from numerator and denominator, and sine theta by 2 will cancel 1 power from the numerator, so we get tan inverse sine theta upon 2 upon cos theta upon 2. And as you know well, sine upon cos with the same angle becomes tan, so sine theta upon 2 upon cos theta upon 2 becomes tan theta upon 2, so we get tan inverse tan theta upon 2. Now tan inverse tan eliminates and we get only theta upon 2. Here 1 upon 2 as it is, and in place of theta, if we assumed x is equal to tan theta, so by the concept of inverse trigonometric functions, theta is equal to tan inverse x. So we write tan inverse x in place of theta over here, we get half tan inverse x. So this is the simplest form for this expression. Now here we arrived at our third kind of sum, which is evaluate a given expression in terms of inverse trigonometric function. So here we have to find the value of tan inverse 2 cos parenthesis 2 sine inverse half parenthesis closed square bracket closed. So first we write the given expression as it is, tan inverse 2 cos 2 sine inverse half is equal to, and when there are more than one brackets in an expression, always remember we need to start the calculations or simplification from the innermost bracket. So we have to start simplification from here. So tan inverse as it is, square bracket as it is, 2 cos as it is, and parenthesis 2, and now we have to write down the value of sine inverse half. So as I have explained in my previous video, the concept of inverse trigonometric function, sine inverse half means that angle for which sine has the value half. So that is 30 degree. So we write 30 degree or pi by 6, whatever you write. In the degree we write 30 degree, and in radian measure we write pi by 6. So next tan inverse 2 cos 2 into 30 degree becomes 60 degree, and now tan inverse bracket as it is 2 into. Now we know well the value of cos 60 is half, so write down half. Now 2 is cancelled by 2, and finally we have tan inverse 1. So tan inverse 1 means that angle for which tan has the value 1, which is 45 degree or pi by 4 radian. So 45 degree or pi by 4, and that's it. Now here I have explained all the three kinds of sums. Now I'll give some quick solutions to some of the important sums.